Alright, the goal of this tutorial today is to demonstrate the process for obtaining volume data from medical imaging data. Specific to this tutorial, we're going to be using a data set taken from canines. The points that are the starting material are metal markers inserted onto the diaphragm of the canine. When the dogs are subjected to specific breathing maneuvers, X-ray images are taken at discrete time points. Each of these maneuvers has two sets of points. There's the reference and the experimental or the deformed state. From a top-level perspective, there are three things we're going to do in this tutorial. The first is we're going to take the points that correspond to exact positions of the canine diaphragm, and we're going to convert them into lines that follow the surface of the diaphragm. The second thing we're going to do is we're going to convert these lines into a surface that approximates the diaphragm of the canine. The third thing that we're going to do is that we are going to create volumes between the reference and the experimental or deformed state that will provide quantitative results of the amount of positive or negative volume displacement of the diaphragm during a breathing maneuver. We provided a template file which has the layers organized in a way that will simplify the process of generating volumes from this data. To access the template, you simply type new or new file, and here you can see that it is listed as diaphragm. So when we open this, as you can see from this template file, we have our layers organized into our deformed and our reference, as well as our volumes, and then there are two scratch layers that will allow you to do reference geometry without polluting the other layers. So each of these deformed and reference are broken down into three sub-layers, and those are points, lines, surface, and then the volume itself is broken into positive and negative displacement. So let's start with a review of Rhino before we do anything else, just so that we can refresh our memory. Again, we're working with Rhino 5, so if you're working with Rhino 4, there shouldn't be any difference in the functions that you're using, but visually you may be able to see some sort of difference. So what we're going to do is, let's remind ourselves how to rotate around a scene. So in Rhino, rotating around a scene is right-click and drag. In order to pan the scene, you hold down the Shift key and you drag right. There are two ways to zoom in Rhino. The first one is to hold down the Control key and right-click and drag, and that's a smooth or continuous zoom. And the second one is just an incremental zoom where you roll your mouse button. Let's remind ourselves how to select objects in Rhino. I'm moving over into this right area now. Two ways to select in Rhino. Now, first of all, if I draw a box from the left, I draw a box to select, I have to completely envelop the object in order to select it. If I draw a box from the left and I do not completely envelop the object, it does not get selected. So the other way to draw a box is from the right in Rhino, and if you notice that if I draw a box from the right and I completely envelop the object, it selects it. But what you'll notice here is if I just draw a box and I'm just touching this object, it will also select it. There's another advantage of Rhino, and it's the middle mouse button as the pop-up menu. So when you pop up this, and you hit the middle mouse button, you get this pop-up. A number of the functions that we'll be using frequently are actually in this pop-up, which is included in the template file that you'll be able to open. So you can just close this in order to move on. The last thing is that the dialog box up here allows you to type specific commands, like cube or curve or split. So sometimes I'll be using the dialog box in order to type commands when it's faster than using my mouse. So at this point we're ready to begin working with our data. The first step is to import our data. So we want to first begin by typing, and if you type it, if you click into the dialog box here and you type import, notice that it auto-completes. We're going to select import. we're then going to go to, we're going to start with the reference geometry first, and in this one we're going to be doing pro TLC occluded reference. So the points import option is what you will see after you select the text file. And you have delimiters. Delimiters are how the data is actually separated. And there are 5. So there's a comma, semicolon, space, tab, and then other, in case you have a delimiter, which is a non-traditional character, say like a caret or something, or a period or something like that. So you also have this option to create a point cloud. A point cloud will import all of your points, however many they are, as one object, and none of the points will be editable individually. We don't want to create a point cloud because we're going to be working with these points individually. So for this, I have my delimiter set to other. You may need a space or a tab, so this is something that you're going to need to change. I'm going to go ahead and click OK, and you can see that we have our points here in all 4 views. We really only need to work with the perspective view with this type of data, so I've double-clicked on that word, and if I double-click again, it goes back to the 4 views. So I've double-clicked on perspective. I'm looking at the points here, and I want to get a better view. So I'm just going to do zoom. I'm going to zoom in, and then I'm going to zoom out a little bit. All right. So this is the diaphragm data that we're working with. We want to immediately make sure that we're working with the right layer. And in fact, this is our reference layer, and I imported it into the points layer of deformed, and so that's not correct. So what we're going to do is we're going to move all these points into this points layer here. It should be purple. So there are a couple ways to do this. I'm just going to hold down Control A, and then I'm going to type change layer, change layer, and it auto-completes. And then I'm going to select reference and points and select OK. And then I'm going to make sure that I'm working with that layer. I'm going to turn off this deformed layer just so I remember that I'm not working with it. And in terms of reference here, what I can do is, since I know I'm working with TLC occluded, I'm going to go in and type that into my deformed so I have a record of it for the future. And then my reference can stay as reference. So at this point, what I'm going to do is I'm going to hide it. And I'm going to actually work with the deformed. And we're going to complete this process again. So I'm going to go import, type to import, and we already did pro TLC occluded reference. Now we're going to do pro TLC occluded deformed. Click open. Okay. Points import. We're going to do other. I'm not going to create a point cloud. I'm going to click OK. All right, and there we have these points. So if I turn on both my reference and my non-reference, you see that these points sort of overlap. This is in the Z direction. So if it may be difficult to see now, but what we're going to do with these points is we're going to connect them to create lines. And right here, and right here, and right here, and right here are where we have the lines that we're going to be connecting. And as we work through the data, you'll begin to be able to visualize these points. I know they look like they're very confusing now, but it'll become very clear very soon. So I'm going to work with the reference geometry first, and I'm going to create lines and a surface so that you can see that. And then we'll go back and do the deformed. Each of these has points. 1, 2, 3, 4, 1, 2, 3, 4, and we're going to work through this to create lines. So there are at least 2 ways to create lines, and it's important to select the correct way. So we have 2 ways to do this. So the first one would be, I'm going to open my middle mouse pop-up here for you. First one would be a control point curve. Notice if I left click, you can do a control point curve. The second way would be a curve through points. So if we do a curve through points, let's try that first. Right click, and then let's select. We notice that it asks us to select the points to build a curve through. So I'm going to select this one, this one, this one, and this one. And then I'm going to hit enter. All right. And we have a 3rd degree line and interpolated with uniform knots and not closed. And that is correct. So we're going to hit enter. In the future, what you can do is you can right click to do the enter button. So as we see, this line goes directly through all the points. Let's do this again, but let's instead use a control point curve. So a control point curve has weights that are that can be modified by you. And what you'll see when I left click, left click, left click, and left click, and then I press enter to finish. What you'll see with this control point curve is that it does not follow immediately through these points. So for our data, this is wrong because these metal markers that now are visualized as points correspond to the exact surface of the diaphragm. So we're going to delete that. And so that's a visual explanation of why you actually want to use curve through points, which is the right click of this function. So we're going to go through and right click, and I'm going to build these curves through these four. Press enter to select. And then I have these four here, 1, 2, 3, 4. So I can actually pre-select them. I can right click, do that. I can right click for enter. Now we're going to do these four. Again, right click here. Enter or right click to accept. Okay. Then we have these four. 1, 2, 3, 4. Enter, enter. And we have these four here. 1, 2, 3, 4. If we right click curve through points, you can quickly generate that. Right click to accept. And then we have these four here. 1, 2, 3, 4. So we're going to stop with the data here. This portion of the diaphragm gets quite complicated, and it's not necessary for this tutorial for you to understand how to do it. So we're actually just going to delete these points. Let's go ahead and delete these points. All right. So at this point, we've got lines through our points. But one thing that we did not do was make sure that we were working on the right layer. So we're working on the deformed in the points, and we have these lines. So we want to change these lines to the right layer. So we're going to go and select all of them, and we're going to type change layer. See there on the top, change layer. We're going to hit enter. And we're going to change it to lines of TLC occluded deformed. Okay, notice that the colors changed slightly. It's a little difficult to see. All right, now that we've done our lines, let's go and let's do the lines for the reference points. So I'm going to switch my layer to reference and points, and I'm going to turn off the points and the layers for the TLC occluded deformed, so it's easier for me to visualize. Okay, so again, 4 points. So 1, 2, 3, 4. If you look down, you can sort of see them. It's like looking at a constellation. This will get easier for you to visualize as you continue to do it. So right click, 1, 2, 3, 4, right click, enter to accept. We're going to go a little faster now. I made that one twice. All right, so right click, right click. All right, we've got these four. We've got these four. And we have these four. Okay, and so again, we need to switch layers. We need to change the layers of these lines to the appropriate layer. So it's reference, and we want lines. Click OK. And again, we're just going to delete this data because we don't need it for this tutorial. Okay. The final thing we're going to do on both the reference and the deformed state is connect these points up here. Connect these points up here because those are going to form the border of our volume. So I'm going to right click again, do curve through points, and I'm going to select these points. What we're setting up is a network of curves right now, and you'll see why that's important in a second. All right, so now we go and we select these points again. And we'll do the network curve again. So what you're looking at now is actually a wireframe of a surface. So so we're going to do that with the deformed as well. So I'm going to turn on the points and the lines, and I'm going to change my layer to deformed lines and turn off points and lines for the reference. And again, we're going to right-click on curve through points and select this one, and this one. Right-click and right-click, and then we're going to do it again. Right-click this point here, 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 and here, and right-click, and right-click, and you again see the wireframe of this surface. So at this point, it's time to start building the actual surfaces themselves. So there are a number of ways to do this. For this type of data, network of curves is the best route for you to take. And I'll go over a couple others, but it's important to note that in the same way that using a control point curve versus a curve through points can actually get lossy for your data. And so curve network, again, follows with our trend of matching the exact surface of the diaphragm. So let's do this with network curves and to see what the process is. So if we left click on this, it's going to say select curves in the network. And one thing I can do is I can turn off the points here, and I can actually just do Control A. And it says select curves in the network, press enter when done, and you see that there are 9 curves selected. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9, and that's correct. So we press enter, and now it says, look, you've got A, B, C, and D. Okay? And if we press enter when done, you see that this surface has been generated through the actual curvature of the lines. In fact, if we select curve, typing in SELCRV and hit enter, you see that the surface goes right through those lines. Okay, so let's change the layer of the surface, change layer to the surface of the deformed, and click OK. And then let's go and do the exact same thing on the reference. So we'll just turn off the master occluded deformed layer, and we'll turn on our lines. We don't really have to work with the points at all anymore. And again, we can select left-click network, surface from network of curves, and Control A to select all the curves, and then press enter. It'll ask us, is this the right order? A, B, C, D, and it is. And if it was A, C, B, D, what you'd see is that the surface would be inverted or twisted. So that is, so we can click enter, and there we have our surface. Okay, so let's change the layer of this, change layer to surface for reference. Okay, and let's go ahead and hide our lines. Okay, so at this point we have 2 surfaces. We clearly have our reference surface. It's purple, you can tell that. Okay, and you can check the layer. And we also have our occluded, deformed TLC surface, and that's red here. So the next step that we're going to do is we're actually going to overlap these surfaces and create volumes. And so that's where our positive and negative volumes come in. So we're going to take this data and we're going to copy it into a scratch layer, because there are a couple extra steps to this process, and we're going to be working with it for a while, and we're also going to be chopping it up. So we want to leave these as is, but we want to copy them to a new layer. So we type copy and then to and then layer. And you can see that up there. Copy to layer. So hit enter, and we're going to copy them to this scratch layer here and click OK. Okay, so what you notice is that you still have the purple, which is the reference surface, and you still have the red, which is the occluded deformed surface. But you also have this other one. So when I click to here and I turn off surface and I turn off the surface for the TLC occluded, you see that you have these 2 surfaces. So let's talk about the generation of volumes in a very top-level fashion. What we're going to end up with in the end of this entire procedure is this volume here being boxed off into separate parts. And the definition of separate parts is actually where these reference and deformed geometries overlap. So when they overlap slightly here, we're going to get a volume segment that's going to span this length. And where they overlap here, we're going to get a volume that spans this length. So the same rule of thumb applies for the volume segments as does the lines and the surfaces. And so we want to try and minimize error. Because we have points taken directly from the surface of the diaphragm, the difference between the controlled and the experimental is a simple linear transformation. So in this case, we are going to just draw a surface from here to here and from here to here. So let's start defining our positive and negative regions. So in this case, we're going to have one large positive displacement and one small negative displacement. So the negative displacement is going to be right here. You can see that. The positive displacement is going to be this region right here. Okay, so we need to figure out a way to define the volumes that we will use, and that is the intersection between these two surfaces. So we have several ways to do that. One of those ways is with an object intersection. The other of those ways is by doing a Boolean. We're going to do the object intersection. So what I'm going to do is select both of these surfaces. For the second one, I hold down Shift, and then I'm going to click object intersection. And so it's going to say it found one intersection, and that intersection here is shown along this path. Now if we look underneath, we can see that this intersection is clearly based on the actual intersection between the two surfaces. And we are just going to make an assumption here that this line will go and move immediately along this surface. In order to draw this line here, we want the curve to be exactly on the surface. And so we have a tool underneath the curve submenu that's called Interpolate on Surface, and I've also added it to the pop-up menu. So if you left-click Interpolate on Surface, you first are prompted to select the surface to draw the curve on, and it's this one here. And then you need to start the curve. So the start of the curve is going to be the end of that curve. We'll then select, click, and then we'll just move to the end of that curve and click, and right-click to close. We now have a curve which runs along the surface of both of these, and then it ends and comes out on this surface. So I'm going to join these curves. So I'm going to type join. I could also click this button up here in the pop-up, which is called join. And then we're going to do the exact same thing on the other side where the intersection lies. So again, we're going to use this interpolate on surface. We're going to left-click the surface. We're going to start the curve at the end of that line, and we're just going to move to the end of this line. Left click and then right click to end. And then we're going to again join these two lines. Join these curves. Join. Okay, so what we have here is a line that defines the intersection between these two surfaces and also where we're going to draw our negative volume. So this line also will cut this surface here on both ends. So the next step is to split these surfaces into the regions that we will then use to define our positive and negative volume. So I'm going to left click here, and I'm going to type split. Also, I can do this right here, which is split. So I'm going to type split. My cutting objects, first of all, actually, let's start over. I'm going to type split. I'm going to first select the objects to split. In this case, it's this volume. I'm going to hit enter once I've selected that. And then I'm going to select my cutting object, which is, of course, this line. I'm going to select the curve. I'm then going to click enter. And it will say one surface split into two pieces. And if I select, we see that we have a separate surface. Then I'm going to do the same process for this other surface, which happens to be the reference surface. I'm going to type split. I'm going to select my cutting object, which is this curve here. And then I'm going to hit right click, and it says one surface split into two pieces. And indeed, if I select this, I can see that that's correct. So why don't we start by making this small volume first. I've selected both of them. I'm going to make it easier for us to look at what we're actually talking about here. And that's something, this is a command that we're going to use pretty often. So I'm going to type invert, and that inverts our selection. And I'm going to type hide. So hide will just simply hide our objects. And then I want to center, so I'm going to move over here and I'm going to type zoom extents. So what we're looking at here is two surfaces. In fact, if I hit Control A, I can see two surfaces at a selection. So we're going to close this off into one volume. And we're going to do that by drawing lines between these points and making surfaces. So let's start by joining these two together. Join. And you can see that two surfaces or polysurfaces joined into one open polysurface. Now, if I type duplicate borders, what you'll see is that there's this region here that's open that we need to fill. So this is a fairly complex region. So what I'm going to do is I'm going to break it up. I could actually use one of these other surface techniques that we have, like patch, which is right here, to make a surface. What it's going to ask is what the U and V spans, which would be the demarcations that are control the surface. And I'm going to click OK, and we can see that. So that one's OK, but you can see that there's a little inconsistency right here, and that's not what we're looking for. So we want to delete that surface. I could also do this surface from 2, 3, or 4 edges. That's another option. So if I select the curve, it's currently one curve. But if I explode it, what I get is 4 segments of a curve, which would be 1 and 2 and then 3 and 4. And then if I select this surface from 2, 3, or 4 edge curves, we see is it more closely matches the curvature, and this is about what we want. But I still see there's a little bit of geometric inconsistency right here that I don't like. And so we're gonna try and break this down into a smaller problem. So I'm gonna delete that, and I'm gonna draw a line from here to here, and then I'm going to just make that as one surface. So for this, I'm going to use just one line segment, which is in the pop-up menu. I select line, I rotate so I can see it, and then I'm just going to go near and then near. And since I have this surface here, this curve and this curve here that is too long, I want to be able to select a line that starts back there and stops here, and a line that starts here and goes over there. So I already have this line, and I already have this line, but I need to cut these two lines right here. So I'm going to select split, and it's asking me to select the cutting objects because I already have the objects that I'm going to split selected. And I'm just going to select this line, and I'm going to press enter, and what you'll see in the dialog box is it says 2 curves split into 4 pieces. And indeed, if I select this curve now, you see that it ends here. So let's select these 4, and then we are going to do a surface from 2, 3, or 4 edge curves. And I click that, and that's what I come up with. All right, so this is part of what our volume is going to look like. You can notice a very slim volume. Let's start taking steps to close this volume. So I'm going to select all of my surfaces, and I'm going to type join. And it says 2 surfaces or polysurfaces joined into one open polysurface. Okay, and the only open part of the polysurface can be found by selecting the polysurface and typing dupe border. And indeed, it is right here. Okay, so I'm going to clean things up a bit. I'm going to select this, which I do want. I'm going to type invert, and notice that it inverted to 8 curves. I'm going to just delete that. I'm going to start fresh. So it allows me to see what I'm doing. So I'm going to again dupe border, and now I have this. So if I break this up by typing or clicking explode here, you see that it explodes into 4 segments. And if I try this network curve, you see that we still have a little bit of this geometric inconsistency, and so we're not going to do that. So I'm going to undo. I'm going to parcel this surface out even more. So what I'll do is I will do a line to here. I will do a line right here. Then I'll do a line up to here. And then I'm going to again split these curves by this line that I've bisected them with. And then I'm going to select all four. And I'm going to do network. Okay, and so I still see a little bit of that geometric inconsistency. So I'm going to go back a step. I'm going to further subdivide this. Delete. I'm going to add another line, and it's going to be from here up to here. And then I will further subdivide these curves. And then I will do, again, select all four of them. And select surface from 2, 3, or 4 edge curves. Looks better. You've got a little problem here, but I'm going to assume that that will work itself out. And so again, what I'm going to do is I'm going to select my new surface, select my poly surface, join, and I'm watching to see that it actually says successfully joined, because sometimes it will not. And that's when you have problems that you need to troubleshoot. So I'm going to again invert, delete all my curves. I'm going to duplicate my borders again, and here we have these. And then I'm going to explode these into 4 segments, and I'm going to then select surface from 2, 3, or 4 surfaces. And here I definitely have some geometric inconsistency. You can see this discoloration means that the 2 surfaces, this one and this one, are overlapping, which is not what we want. So I'm gonna try and deal with this region here first. So I'm going to delete this surface. I'm going to draw a line between here and here. And these aren't arbitrary. Notice that the curvature changes here. So I'm trying to catch it right before the curvature. And then I'm going to split that line at this point. Split. Okay, successfully split into 4 pieces. 2 into 4. So I select that part of it. I select this part of it. I select this part of it. And this part of it. And then again, surface from 2, 3, or 4. And I'm still seeing an issue here. So what I can do is further subdivide it. So let's get rid of our curves. So select curve, delete. Let's go a different direction actually. What if we go this way? What if we draw a line from here to here, and then it's 1, 2, 3, 4, and we can deal with the rest later. Okay, so let's duplicate our borders. Let's draw a line from here to here. Let's draw a line from let's do this. Let's draw our line by exploding and then doing our network curve. And let's do the interpolated curve here. Let's select this surface. Let's go near. Let's go to there. Okay, let's close it. And let's delete that reference geometry. And then we have this. We have this line here. We have this line here. Let's split that by this line we just drew on the surface. And let's select 1, 2, 3, and 4. And let's do a surface from this. Okay? So here we have something that I can work with. So I'm going to left click, I'm going to select our poly surface, and I'm going to join. And again, 2 surfaces or poly surfaces joined onto 1 open poly surface. I'm going to delete this. So now we have this to contend with. So do border, we now have this 4, and let's see if we can explode it and try our surface and see if that fixes it. And what I notice is that the geometric inconsistency is a little different now. Not necessarily better, but that's what we get from doing this reference geometry here. And so what we'll do is, it's still not perfect, so I'm going to just delete this, and I'm going to see if we can further subdivide the surface. And then if we can't get it, we need to simply move on. Okay, so I've selected this curve. I've selected this curve. I'm going to split it and right click. So I now have this curve, this curve, this curve, and this curve. I'm going to do this surface. And at this point, I've tried 3 or 4 different times to fix this, and it hasn't been fixed, so I'm not going to worry about it. I'm just going to move on. So this is how it goes. If you, it's just a visual indication that there's a geometric inconsistency. It's not necessarily going to affect our results or give us an incorrect answer. It's just due diligence. So here we go, and I'm going to select all my curves and delete them, and then I'm going to select everything and join. So just a note about this final join step. What I'm looking for is, instead of saying one surface and one poly surface joined into one open poly surface, I'm actually looking for it to say one closed poly surface, and that'll give us a volume, and that volume is the result that we're looking for this entire tutorial. So let's go ahead and click and type join. All right, so in fact, 3 surfaces or poly surface joined into one closed poly surface. So closed poly surface should give us a volume when we type volume. Okay, and indeed it gives us a volume of 0.051185 cubic millimeters. So we've now completed this volume. What we want to do is now move this into the negative volume displacement. So we select it and type change layer. We move to negative displacement. Click OK. You just go ahead and hide that. Now, remember, we had all of our other volumes, all of our other surfaces that we simply hid for a second. So let's type show, and now we have them again. All right, so this is all going to be positive displacement. What we need to do is go and draw lines that we will then construct surfaces from. So first thing to do is just draw lines. And since these markers are in the same place on each dog, what we're talking about is an actual sort of a translation and rotation. But this point is the same as this point. So we can, for the most part, actually just connect them. So that's what we're going to do. Still working on scratch layer. We're ultimately going to end up with this in the positive displacement layer. But for now, we're just connecting them. All right, there's one. And for here, we've already got this point, which is connected from here to here. So it would actually create a geometric inconsistency if we did, in fact, connect those. So we're not going to. I'm going to go around to the back, and I'm going to connect these 2 points. So I can right-click to redo last action. I can hover over this end, go to this end. I'm going to do the same at this tip here. Right-click, left-click the end, left-click the end, and I can also do the same thing here and here. So zoom in, right-click, left-click, left-click, done. And actually for this one, let's see if we can, I can see there's going to be some issues with this surface here, probably. Let's actually try and do this one first, because it looks complicated and it'll be a good example. So we left-click, we don't have this line. I'm trying to select that line, and that's because we need to duplicate the borders. But also you'll notice that these aren't joined. So that's our first step. Join these surfaces, join. 2 surfaces or poly surfaces joined into one open poly surface. And then we're going to duplicate the borders, duplicate borders. All right, so what you can see here is a visual indication of what we have yet to do. So this one border, which spans the entire length, needs to be split along this line right here. So we're going to do that now. I've selected split, and now we're going to select the cutting objects, which is right here, right-click. It's split into 2 pieces. We also need to split it here. I should have done that. So we're just going to redo the split. Left-click, split, select the cutting objects right here, right-click, and 1 curve split into 3 pieces. So now we have 1 curve, we have 2 curves, 3, and 4. And let's see what happens when we actually do this surface from 2, 3, or 4 edge curves. Okay, so that actually looks perfect. And I think we're going to go with it, except right here, it turns in on itself. So this is probably where problems can occur. And so we're going to move forward with selecting it, but we're going to know that we might need to come back and fix this particular part. You might be asking yourself, where does it turn in on itself? And it's a little hard to see, but it's right at this point here. Okay, we're going to join it and just indicate, or just remember that for the future we may have a problem with that. So I'm going to select it, I'm going to select this, I'm going to type join, and then we're going to invert. We're going to delete our curves, and then we're going to duplicate the borders. Okay, so this is good news. Okay, we see that this border is here. Sometimes when you get a bad join, you'll actually see that the line is still there, and that means you need to explode or start over. So let's do this little region here. Let's do this region here. So we're going to select this curve. We're going to explode it. We should get 4 curves. We might get more though. 4 segments. Click to close, and we have what looks to be an okay surface. So let's do this again. So select our surface, select our building volume, type join, and now we're going to duplicate the borders. Actually, we're going to invert first. Invert, delete our reference geometry. Now we're going to duplicate the borders. And so we notice we do not see a line here, which means that it's closed. That's good. All right, so this large region is going to be very interesting. Let's do this part right here so we can close that off. So I already deleted that line by accident. That's okay. Left click, and then we split this curve. Split by that. I'm then going to select this curve, and I'm going to explode it. And it explodes into 3 segments. Add the 4th, and then select surface from 2, 3, or 4, and rejoin 2 surfaces into 1 open polysurface. Invert, delete our curves, select it again, duplicate the borders, and we see that we are good. All right, so let's do this region right here, joining these points. And we want to then split them by this curve. Let's select this curve, let's explode it. Explode into, oops. Select this curve, let's explode it into 3 segments. And then let's select this one for our 4th. All right, and that looks like a great surface, so we're good with that. So let's select it, select this, let's type join. 2 surfaces of polysurface joined into 1 open polysurface. Invert, delete our curves, duplicate our borders, and it looks like we just have this one last border to contend with. So this is fairly long. I'm going to explode it, and then I'm going to do this edge curve so you can see what it looks like. So this actually looks okay because it's connecting line to line. So there may be more complicated or different ways in which you need to join others, but for this particular volume, we're okay. So our final step is to select all of our surfaces. Let's first select our curves. Let's delete those. Let's select our polysurface and our surface, and let's type or click join. And indeed, it says 2 surfaces or polysurfaces joined into 1 closed polysurface. Okay, and we can type volume. We see that volume is 9.439 cubic millimeters. At this point, we're going to change layers to positive displacement, and then we're going to turn on negative displacement. And what you're visualizing right now is the final product of this tutorial, which is the reference and deformed state of the canine diaphragm after a maneuver called TLC occluded deformed, and the negative volume displacement and the positive volume displacement. The end products of this would be this 3D file, the lines, points, and surfaces corresponding to each of the surfaces, and also the volumes that you would obtain from both the positive volume displacement and the negative volume displacement.